So this is the Chapter 1 practice test to help you prep for the test. So find the equations of the lines that pass through the point 0, 4. Now you should probably notice that 0, 4 is a y-intercept. That's kind of a useful thing. Y-intercept, might as well spell it correctly, that are A, parallel, and B, perpendicular to the line 5x plus 2y equals 3. So the first thing you need to do is take 5x plus 2y equals 3 and figure out the slope by solving for y. That is to put it into slope-intercept form. So you subtract 5x from both sides, then you divide by 2, which means that the slope of the original line is negative 5/2, which means that for the parallel, the slope is going to be negative 5/2, the same. And for the perpendicular, it's going to be the opposite, so positive, reciprocal, so 2/5. There's a couple ways to write the equation of the line, especially because we know the y-intercept. You could write it in slope-intercept form in both cases and be done. Or you could write it in point-slope form. So if they didn't give you the y-intercept, point-slope form would be easier. But remember, x goes with x, y goes with y, so it would be y minus 4 equals negative 5/2 x minus 0, and y minus 4, 2/5 for perpendicular, x minus 0. And you're done. Number 2, find the slope-intercept form of the line of the equation that passes through these points. So we're going to find the slope by finding the change in the y and the change in the x. 4 minus negative 1 is 5. So the slope is 5 over negative 5, aka 1. So slope-intercept form. So that means I've got the slope. I'm going to use this point in this form of the equation by plugging in x for x, y for y. I just happen to pick a point. So this is 2 plus b equals negative 1. Subtract 2, b is negative 3. So don't forget to write the final answer, which would be x. It's okay. You don't have to write 1x because the slope is just 1. Ooh, I'm sorry. It's negative 1. Negative 1. That changes all my answers, doesn't it? So I add 2, and this actually, see, look, errors do happen. This becomes 1, which means that this is negative x plus 1 for my final answer. Does this represent a y as a function of x? And the answer is no. More than 1y for a given x. All right. Find all of these. So f of negative 8 would be plugging in negative 8. Now, negative 8 plus 2 is negative 6. Remember, order of operations says do everything inside the absolute value. Then you take the absolute value, which is 6, minus 15 is negative 9. F of 14, same thing. You plug 14 in. 14 plus 2 is 16. It's 15, the absolute value of 16. I'm showing a lot of work here. That's it. Now this last one, because it's f of t minus 6, is going to have a variable for an answer. You just want to simplify it as much as you can. So this is going to be t minus 6, and if you're not sure, you can put it in parentheses. In this case, it turns out it doesn't matter, right? T minus 6 plus 2 is the same as t minus 4. Take the absolute value. And actually, we are done, because that's as far as you can take it. Don't forget this, we are taking the absolute value of that. Notice how t is still there. Find the domain of, so what we're looking at is a function as a square root function. So we're going to need to focus on this square root and figure out, are there any values of x that cause a problem? So when is 3 minus x equal to 0? Well, when x equals 3, because 3 minus 3, right, is the square root of 0, which is okay in my book, right? So it's okay to have 3 in there. What sort of values don't work? Well, if I were to plug in, I don't know, 4, what would happen? No. So what does this mean? It's okay to have 3 in there for a domain. It's okay to have 3, but I had to have any number that's what? Smaller than 3. So maybe I need to shove this over. Let's go ahead, and it means that I'm looking at numbers that are smaller than 3, which means negative infinity, which always comes first, then 3 is my upper limit. Okay, just like that. All right, produces a car stereo with a variable cost of $24.60 and fixed costs of $25,000. So $25,000 no matter how many you produce. The product sells for $101.50. Write the cost as a function of x, and then write the profit. Now profit is equal to your income minus your costs. That's in general how that works. So what we're going to do is we're going to come up with an income equation too while we're at it. Okay, so we know that for any given number, x of these things, we're going to make $24.60 for each one. So 24.6, so the cost is, right, 24.6 times x is how much it's going to cost. So if I make 1, it costs me $24.60. If I make 2, it costs me 2 times that. But then I also have a fixed cost of $25,000. So no matter what, even if I make 0, it costs me $25,000. Next, income. The product sells for $101.50. So if I sell 1, how much do I make? $101.50. If I sell 2, how much do I make? $101.50 times 2. So now I just take these two equations and combine them, right? Oops, don't want to do that. 101.5x minus all of, this is kind of important, the costs. So when I'm subtracting this, I get 101.5x minus 24.6x minus 25,000. No like term there, minus 25,000. 101.50 minus 24.6. So what is that? That is going to be, if I subtract 0.6, oh, help me. 101.4, so 24.6 is going to be like subtracting 25, which is going to be 75, so 76.50. Then add 76.50 plus 40, so what, 76.90 x. And that is what my profit is. So this tells me if I sell 0, my costs are still 25,000. And at some point, I'll actually start making a profit. Remember, a lot of businesses are not profitable until they've done a certain amount of business. Okay, algebraically, whether it's even, odd, or neither. So we need to figure out f of opposite x. And do what? Well, that means 2 times negative x cubed minus 3 times negative x. So f of opposite x, which is negative because of cubing it, is the same as, right? Minus a negative plus. These two do not match, so f of x is not equal to f opposite x. So we need to go on to find opposite f of x, which means taking the opposite of both of these, which is, and if you look, these two match, so therefore odd. Same. Always start with f opposite x. So it turns out in this case, we have a pretty, so when I raise anything to the 4th or the 2nd, it doesn't change it. So it's the same as this. These are the same, so therefore this is even, less work. Okay, determine the open intervals on which the function is increasing, decreasing, or constant. So this first function, what we're going to do is we're going to graph it. And it turns out this graph looks like a nice W. As a matter of fact, it looks something like this. Now, I don't really care about what these intervals are, but I do know that this is 2, this is -2, and this is 0. So I see, remember, we're going from negative infinity, that's where we start, to positive infinity in the x, right? I see a decrease, right, from negative infinity up into, but not including, -2. And then I see an increase. We'll just go piece by piece here, right? an increase from -2 to 0, right? It's going up. Then it goes down again from 0 to 2. And then it goes up again from 2 to infinity. And that's it. Now we could say that this is constant at x equals -2, 0, and 2, because that's where it's changing from increasing to decreasing. If we look at g of t, its graph looks something like this. So -2, -4, and this is 2, 4. Someone graph these in advance. You'll never guess who. Now what this means is we have our increasing, decreasing, and constant. So increasing, it's increasing between, now this is where you need to be careful because it's always about the x values. Between -2 and 2 is where it's increasing. It is not decreasing, ever. Exclamation point. Where is it constant? Now it turns out, because we have this long interval from -infinity all the way up to, but not including -2, and from 2 to positive infinity, right? This region and this region is where it's horizontal. Okay, use a graphing utility to find and approximate to 2 decimal places relative maxes or mins. So what I did is I graphed these, and I discovered that this graph looks something like this. This is where Desmos is great because you can graph this pretty easily. Oops, hold on. Turns out it's like this, it's like that. Now it turns out that this point here is 0, 12, and this point here is -3.33, -6.51. All that remains is to state what it is. This is a relative max, local high point. This is a relative min, local low point. Similarly, if we graph x cubed, blah, 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 then what do we get? We get a graph that starts down here, goes up, hits a max, comes back down, does a little cubic kind of jink, and then comes back up like this. Now these points aren't near as nice. This point here turns out to be -1.34, 6.89. And this point right here works out to be -1.34, sorry, positive 1.34, 1.10. At least it's symmetrical, right? That's kind of handy. Now, that being said, what happens? Well, we now identify this as a relative max, and we label it, and this is a relative min. Remember, we're looking at this point and this point. Nice little closed little box there to see what's going on. All right, identify the parent function. Easy. Y equals x cubed. Y equals square root x. Y equals absolute value of x. Those are all the parent functions. Transformations in order. So what's the first thing that happens? This thing gets -5, aka gets shifted this way 5, or to the right 5. Then what? Gets multiplied by 2 and then negative, right? So sequence of events, 1, 2. You have two choices. 2 and 3, it doesn't matter which order. So you could say that's reflected over the x-axis because of the negative, and then vertically stretch factor 2, or you could flip them because the negative and the 2 kind of happen at the same time. What is definitely the case is 1 must be the shift 5 units to the right, and the last thing, number 4, is the, oops, not downward, upward shift of 3. Okay, arrows or words work. All right, similar sort of thing here. So what's happening with this? So it turns out that the very first thing that's going to happen is we're going to have, well, we're going to have a couple of different things happen. First, we're going to have a reflection over the y-axis because of the negative that's directly affecting this. We're also going to have a horizontal stretch factor 7 because we're multiplying by 7. Now, then to figure out what the shift is, I need to, see what I did there? I factored that out. Then we can figure out that this has been shifted this away 2 units. That is left 2 units. These two, actually it does happen such that it reflects and then does a horizontal stretch. But that doesn't matter in that case because it's tied. But that has to happen before the shift. Okay, so this one even easier because it's simpler still. We have this happening to the independent variable. So this has been reflected over the y-axis, right? And then 2, it has been vertically stretched, factor 4. And last but not least, shifted down 7. Now, the weird thing is, without this negative, that is if I just did absolute value of x times 4 minus 7, I'd still get the same graph because reflecting this doesn't change anything. Okay, use the functions this and this to find the specified function and its domain. Okay, so f minus g of x would mean that we're going to take f of x minus g of x, and actually that's it. There's not much that we can do to combine these. The domain. There is no problem with this, but there is a problem with this. This means that this can be 2, but it's got to be then 2 or lower. So the domain would be negative infinity all the way up to including 2, because it does say find its domain. For b, f divided by g of x, this is going to be pretty easy, is x squared over the square root of 2 minus x. Now the domain is also going to be negative infinity up to 2, but because we're dividing by this, we can't put 2 in there because then we'd be taking the square root of 0 and getting 0. So the big thing that changes is less than strictly 2. That is soft boundary. F composed with g. So notice the open dot there. C. So remember, the dependent thing is that we're plugging g into x. So that means that the domains, now it turns out for f it doesn't matter what it takes, but the limit is going to be with g of x, and that domain is here. So that's going to be the influential part. But we're going to take 2 minus x, quantity square root, and plug it into this. Now the reason that this is because we get 2 minus x, but the domain restriction on the original function still exists, so it's got to be from negative infinity to 2. Even though it looks like it shouldn't, it actually still has the domain restriction of g, which it had originally. D, g composed with f of x is, well, then we take x squared, and then we take the square root of that. So what is the issue there? So we don't have any restriction on the domain of x from this, except now the overall function has a restriction. So actually we can just go straight to domain because there's nothing we can do to simplify this. 2 minus x squared, let's think about this. That would mean if I put the square root of 2 in, square root of 2 squared is 2, then I have 2 minus 2. So now that's my new upper boundary. Another way to look at that is when is 2 minus x squared equals 0, when x squared equals 2, which means x is the square root of 2. Whereas before it was 2, now it's square root of 2. Determine whether the function is an inverse and then find its inverse. Cubic, 1 to 1, okay. So what do? X equals y cubed plus 8, subtract 8, take the cube root, and that is our inverse function. No domain restrictions. Not invertible. So it doesn't tell us if it, so it just doesn't have an inverse, so we're done. No inverse. Just doesn't happen. So this one, x times the square root of x. So let me rewrite this. This is the same as saying x to the 1/2 power, by the way. So what is 3x times x to the 1/2? Why, that would be, this gets people even though it's, so this is x times, so that's x to the first, so we add the exponents. So this is 3x to the 3/2 over 8. Now, by the way, that's the same as saying 3/8 times x to the 3/2. Here's why this is important. When we reverse this, so we get x equals 3/8 y to the 3/2, it's pretty obvious that we multiply by 8/3, that is divide by 3/8, and that gets rid of that. How do we undo this? Remember, this is the square root over 2 of y cubed. So what do? Well, one way to look at this is if I were to raise this to the 2/3 power, what would that do for me? Well, we multiply it, we make it 1, so we get y by itself, which means that we take 8/3 x and we take the whole thing, we take the cube root and then square it. Now, we wouldn't expect you to simplify this very much further, but we could then rewrite this as, and I'll write it in terms of maybe something you see a little bit more, 8/3 x to the 2/3, or you could write it as f of x equals, because we're taking this, the 3 as the denominator, we're taking the cube root of 8/3x squared. Could you say that's 64/9x squared? Sure, why don't we do that? So we could also then simplify that if we wanted to. The cube root of 64/9x squared, because 8 squared, 3 squared, right? We could pull the 64 out as a 4, but let's leave it. Any one of these are okay. And this actually concludes our review. Hopefully that helped.